The triangle one was Monday too. I'm not sure, but you have one on parallelograms for the area of a parallelogram. So this is a parallelogram. Parallelograms have sides that are parallel, and you'll see parallel lines just refers to lines that if they were to continue on forever into space, they would never cross. Now, I freehanded this, so obviously it's not perfect, but basic idea, parallelogram. You guys will know when you see on the shapes, what are on the whatever lesson this is. I think it's Monday too, but I'm not positive. You'll see kind of what I'm talking about. But anyway, I don't have any numbers on these because I wanted to start out by saying, just kind of showing you guys, mathematicians discovered how to find the area for these, all based off of knowing how to solve the area for rectangles and squares, okay? They had the base, or the length times the width. You guys have been doing that since 4th grade, so you guys should know how to solve for just a basic square. Like I said, mathematicians long ago, when they first made these equations for these shapes that aren't rectangles and squares, they based it all off of finding the area for a rectangular square. So what they did is, how can I turn this shape, this parallelogram, this odd shape, into a rectangle or square? And what they discovered is that if they took this triangle here and they cut it off, they would have it actually out, not drawn like me, and they took that off. Okay, they cut it off and they put it over here. They discovered that that triangle filled the space in perfectly, okay? The little bit that was on the top took up here, the points matched up perfectly, and it made a rectangle, okay? So, because knowing that information, they used that information to help them. They used that knowledge to realize that when given, see if I can recreate this on the fly. When given this shape, it's a dotted line here. If you measured from one of these little points, corners here, straight down to make a 90-degree angle, that gave you the height. That was the section that you were going to cut off. So if you measured that, and let's say you got 3, okay? And then you measured this. Now remember, from here to here, they knew was going to get cut off and put over here. So they just said, okay, if I'm just going to cut it off and put it over here, it's going to end up being the same length as from here to here, because this section right here is going to get put over there. So let's just measure from here all the way to here, which is going to be the same as from here all the way to here. Sorry, you didn't see that. From here all the way to here is going to end up being the same length as from here all the way to here. I'm going to move that back a little bit so we can have the whole shape. There we go. All right, so those are going to be the same length. I'm going to erase this line because that might be confusing. Those are going to end up being the same length. This side, and again, my picture is not perfect, but on those ones in your problem, you'll see that this is the same length as that. Now, they might throw in this and say this is 4, and this is 4, and this is 6. Again, guys, just like if you've already watched my triangle videos, these diagonal ones, you don't need them, okay? Because we're going to cut that off and put them over here. We're going to match those 4s up. So all we need is this 3 and this 6. 3 times 6 is equal to 18. There's my area of a parallelogram. Now I can use this whole 6 because I'm turning this into a rectangle. I'm taking that section off. I'm putting it over here. Now I just have the same thing. This is a rectangle now, let's pretend, because I cut it off and put it over here. Now I have length times width, just like I always did when you guys were solving for rectangles. Now, because this is a parallelogram and I'm not going to be cutting up my papers, you guys aren't going to print it off Google Classroom and cut it off and section it over here and everything like that. You're not going to do that. You're not going to turn it into a rectangle. So the mathematicians changed it, since this is a parallelogram now, changed it to base. This 6 is the base times the height. Okay, this 3 is the height. So when you have a parallelogram, you're just doing 3, the height, times 6, the base, okay, and you get 18. Okay, simple as that. Keep the questions coming. I hope these videos are helping. I got this new little pedestal whiteboard, so I'm taping some videos for you guys and having fun. So if you guys continue to have questions, just keep them coming. It's not bothering me at all. Gives me something to do. Hope this helps.